If you've ever felt pressure to cover content quickly by just telling students what they need to know, you're not alone. That instinct makes total sense. In classrooms everywhere, there's an approach to science instruction that shows up again and again, what we might call an information frame. That means we've set up our class to deliver information, facts, equations, definitions, etc., and we hope that all this information sticks with students. That frame is tempting. It feels efficient, especially with so much to cover. It seems faster to just tell students what they need to know. I've worked with science teachers for years, and I've felt that pull myself. But here's the thing. Even though it feels efficient, that approach often doesn't lead to lasting learning, not because of how it's delivered, but because of how people learn. OpenSciEd presents a different way of learning new content using an approach called sensemaking. So what is sensemaking? In a sensemaking frame, students are still learning content, but it's always in service of figuring something out. Instead of just learning about a topic, they're actively working to explain something. They're building their own rich understanding of how things work. Let's get a little clearer about the difference between sensemaking and presenting information, and then talk about why it matters so much. To use a classic example, let's say you're trying to teach about photosynthesis. You could hand students the equation and they'd copy it down. To them, it might be pretty easy to remember. In its simplest form, it's just water, carbon dioxide, oxygen, sugar, an arrow, and sunlight. But what does that actually mean to your average student? Does it make sense, or is it just something they can memorize? In contrast, you could start where scientists did, wondering if a tree grows from a small seedling to a huge tree, but the soil around it doesn't disappear, where does all that matter come from? In order to answer that question, we're going to have to investigate a lot about trees and their environment. We're going to have to think about what they take in and put out, and we'll have to collect data on those inputs and outputs. And then we're going to have to spend some time thinking about what all that means. We still figure out the key components of photosynthesis, but it's something we arrive at by the end and not something we tell kids in the beginning. At first, it might seem like there's a trade-off between presenting factual information and sense-making, but that doesn't have to be the case. You can have an information-rich science classroom in a sense-making frame, and that is a much better way to learn. First, because real learning is about building a web of connected ideas. When students construct understanding step by step to answer their own questions, facts connect to each other and to bigger ideas. The information sticks because new facts make sense together, and they're motivated by students' interest and questions. But when students just memorize isolated information, sure, they might be able to pass Friday's quiz, but without connections to anchor it, that knowledge slips away fast. Second, understanding becomes a foundation. Once students have that connected framework, you can layer on vocabulary, formulas, and details without overwhelming them. New information has somewhere to land. It connects to what they already get, and it actually sticks. So, to come back to where we started, it may feel efficient to just tell kids everything you want them to know and understand. But is it really efficient if it's not effective? In a sense-making classroom, students still learn the science facts, but they learn them by figuring things out. That makes their understanding deeper, more connected, and far more likely to last.